Hi, in this couple of videos we're going to be looking at SohCahToa, but it's slightly different to just finding out an angle or a side of a right angle triangle. In these questions we're going to be using it in a slightly different way to try to kind of figure out what it is they want us to figure out. I hope it's okay for you. Please do stop the video, have a go at each of the questions, compare your solutions, and I'll look forward to seeing you inside the video. Hi, in this video we're going to look at two SohCahToa problems when it's kind of not so obvious, and I just thought it'd be useful for you to have a couple of examples. If you click on the link below, you'll be able to go through to my website, which is 3 Minute Maths, and download these and have a go at them for yourself. However, if you just stop the video, have a go at the question and then compare your solution. So on question number 1, I would point out this would typically be on a non-calculator paper. So although I haven't noted it here, it would be non-calculator. Okay, and the issue with it is that really what we need to know is how many triangular tiles we're going to get around a point. In other words, how many tiles we're going to get in the full circle, which is going to be 360 degrees. Okay, so in order to do that, what we need to do is figure out the size of the angle itself. So what I'm going to do is I'm just going to take one of those triangles and just draw it separately so you can see for yourself. Okay, so it's a right angle triangle, which is good. So every time you see right angle, what you should perhaps be thinking about is SohCahToa or potentially Pythagoras. Okay, and both of those are used quite a lot with right angle triangles. Now in this case I've got this, which is 3, and this, which is 6. Now if we're trying to work out this angle is opposite to the 3, so I'm going to put opposite there. The longest side is going to be hypotenuse, and the one that's left is the adjacent. Okay, and then as I've done in previous videos, I'm then going to write SohCahToa, and I'm going to make a decision as to which ratio I'm going to use. Well, at the moment I need to work out the angle, and I've got the opposite and I've got the hypotenuse. One is 3 and one is 6, so I'm going to use the sine rule. Okay, now I appreciate, as I mentioned before, this is non-calculator. So what's going through my mind is that if I know that the sine of, let's call it x, which is this angle here, x, is equal to the opposite divided by the hypotenuse, then I know that the sine of x equals 3/6, which is 1/2. Okay, now there are things that you need to kind of remember when it comes to SohCahToa, and I don't want to cover it particularly on this video, but if the sine of an angle is 1/2, then the angle itself must be 30 degrees. Okay, now that's a bit of a leap, but if you check it with your calculator, I'm sure you'll be able to figure that one out using sine to the power of -1. Use the inverse trig, but also there are a couple of different techniques to remember the different sine values for different angles, and I didn't want to cover it particularly today, but I will post another video on that. Okay, so if we know now that this angle is 30 degrees, then really we need to know how many lots of 30 degrees there are in 360. So we're just going to do 360 divided by 30, which equals 12. So he must be able to make or to use 12 tiles to complete the pattern. And that would be the answer to this particular question. Okay, so let's move on then to question number 2. Question number 2 is just frankly a lot of words. There's a whole load of words in it. So really what we need to do is try to put together some sort of picture of what all the words mean and then decide what it is they're trying to ask us to do. Okay, so we've got a 9.5 meter long ladder is placed against a wall. All right, that's fine. So there's my ladder and here's my wall, and guess what, it's a right angle triangle. Okay, we also know it's 9.5 meters long, so that's that length. and it's got an angle of elevation. So the angle of elevation is looking from the bottom, in other words, the ground, towards the top of the ladder, which is going to be, in this case, 42 degrees. Okay, so without reading the rest of the question, I'm now going to start just labeling it up. And I'm going to say that opposite 42 is the opposite. The longest length is the hypotenuse. The one that's left is the adjacent. Okay, so I'm in a position now to start looking at the rest of the question and see if I can answer part A and part B. The first one, part A, is how high up does the ladder reach? Well, basically, they're talking about the opposite, okay? So, again, I'm going to write SohCahToa, and I need to choose which one is appropriate and which one is easier to use for me. Well, I've got the angle, 42 degrees, so I can use any of those. I want to find out the opposite, so it's either going to be this one or this one. I know the hypotenuse, so I'm going to use the sine rule. So what I'm going to say is the sine of 42 degrees equals the opposite divided by the hypotenuse, okay? So sine of 42 degrees equals the opposite, which is what I'm interested in, divided by the hypotenuse, which is 9.5, okay? So if I multiply both sides by 9.5, I get rid of this, and I just get opposite on its own. So the opposite is going to equal 9.5 times sine 42, which is going to be 6.3567 meters. Okay, so good enough is the opposite equals 6.4 meters, and that's to 1 decimal place. Okay, hopefully that's all right for you. Okay, let's have a look then at the next question, which is part B. What is the distance from the base of the ladder to the wall? So here's the base of the ladder. We're going to go to the wall. Now, I'm just going to be a little bit cautious with this one because I've got a couple of options. So what I could say is, well, now I know the opposite is 6.3567 meters, okay? So if I'm looking at part B, I could use SohCahToa, and let's try to figure out which ratio would work for me. Well, I can say, actually, I need to find out the adjacent, so it's either going to be the cosine or the tangent, because actually I know the angle, so cosine or tangent is fine. I know the hypotenuse, that's fine. And I know now the opposite, that's fine. So basically, I've got a situation where I can write the cos of 42 degrees equals the adjacent, which is what I'm looking for, divided by the hypotenuse is 9.5. Okay, so that's one option for me. My second option is I can say, well, actually, I'm going to use the tan of 42 degrees equals the opposite, which is going to be 6.3567 divided by the adjacent. Okay, and really, I've got a choice. Now, my suggestion is that you use the first one. The reason I suggest you use the first one is twofold. Firstly, we know this is 9.5 for sure. So if you've made a mistake over here, then we can't be, we can't rely on that without the examiner sort of saying, yes, this is correct. Also, the other thing is that this is the bottom here. Now, to make that the subject to the formula just requires a little bit trickier type of algebra manipulation. So I kind of prefer this one here because I know 9.5 is correct. I know cosine 42, so I could just use this ratio. You could use that. You probably will get the same answer, particularly if you've got this, but you're not entirely sure because it is part of the exam. So I'm going to say, well, B, in this case, I'm going to use the cos of 42 degrees equals the adjacent divided by 9.5. So the adjacent is going to equal 9.5 times cosine of 42, which is 7.0598. So in other words, to 1 or 2 decimal places, let's call it 7.06 meters, and that is the adjacent. Okay, so those are my 2 answers. And this is also going to be to 2dp for this one. Okay. All right, so hopefully that's given you some idea about the kind of ways in which SohCahToa is perhaps not as obvious when you've got these sorts of questions. Please do have a look in the next video, and if you're not sure about anything, add a comment below. I'll always come back to you. I'll look forward to seeing you inside the next video.